Let's try to understand OFDM as a spectrally efficient scheme. Till now what we have seen that OFDM can be used in order to convert a channel, frequency selective channel, or a channel whose frequency response is not constant over all the bandwidth which you are using. You can convert it and you can use the smaller portion of the uh, total band, and so that the effect of distortion by the channel reduces. But here we see the different aspect of OFDM, where we don't first say that our bandwidth is fixed. Here we see the multiplexing aspect of OFDM. Multiplexing means you are catering more than two users over a same channel. So just take an example of two users, and we are transferring, we wish to transfer RB, rate of the bits which is coming is RB, and we are using BPSK modulation. So since the rate of bit is RB, each of the BPSK line coder we first convert it to, since it's binary phase shift key, 0 to minus 1, 1 to plus 1, and then we further modulate this. So this duration will be 1 over RB, and then we further send it through the cosine carrier. And we remember, if you remember that for BPSK we require the bandwidth as 2 RB. So similarly, if we perform the same thing for user 2 for frequency F2, the power spectral density of this summation of these two signals over the channel, this will go through the channel, and over the channel the spectrum or the power spectral density would something like this. It will be though sync, so I have just used the main lobe because most of the information is inside the main lobe. So bandwidth or the duration of these is 2 RB, 2 RB, and in between we put some guard band, so that when we extract these information for user 1 and user 2 respectively, it will not interfere with each other, or the band, because we remember the band phase filter which we apply at U1 will have such characteristic. It will never have such sharp transitions. So we will put some guard band. So at user 1 we will put a band pass filter centered around F1, and the bandwidth and the width of this band pass filter will be 2 RB. Similarly at U2, since we are transferring information of U2 over F2, we will put a band pass filter at U2 centered around F2. So total bandwidth occupied by this frequency division multiplexing system is 4 RB plus some guard band. Now let us try to perform the same operation using OFDM. And if you remember that OFDM has such characteristic that each carrier is having some spacing, and the spacing we choose such a way that they are orthogonal to each other. So for that, just see how we can ensure that these two frequencies are orthogonal. We have to make sure that f1 minus f2 is integer multiple of 1 over t, or since in our case we want data rate which we are transmitting at rate RB, so we will make sure that the frequency difference is f1 and f2, the separation between them is RB. So if the separation is RB, the bandwidth occupied, this spectrum will occupy this signal corresponding to user 1, and this yellow portion will occupy the signal for the user 2. And here you can see that total bandwidth occupied by OFDM is 3 RB as compared to RB. So what we have to do in order to implement the same setup using, so first we have to make sure that f1 and f2 are separate. So f1 is some value, then f2 should be fc plus rb, and we can implement this setup using, because OFDM can be easily implemented as compared to this. We don't need this type of multiplier etc., and we can further increase the users and similar more users can be occupied. So you can write the bandwidth occupied by OFDM is less and therefore OFDM is more efficient, or you can say that more users can be occupied using OFDM. So OFDM is a more band efficient scheme as compared to normal FDM.